Hi Bachus, Indu ma'am is back with the lesson motion. This is the third part of the lesson. So all those of you who are new to my channel, please do watch part 1 and 2 for a better understanding of motion. Today we will be discussing the topic speed. Well, speed is not new to you. We have very often done sums based on speed in mathematics and science. So, I am sure you all remember speed is equal to distance upon time. How much distance did you cover in how much time? So, when we say the speed of the train is 300 kilometers per hour, it just doesn't matter if the train is moving this way or that way or on a curvious path. In other words, what I want to tell you is, here the direction does not matter. So speed is a scalar quantity. Speed is a scalar quantity. Well, there is one more thing we realize from the formula. It is distance upon time. So what is the unit, SI unit of distance? Well, it is meters. And the SI unit of time is seconds. So how do we read it? We read it as meters per second. And now that we are in 9th, we have learnt a novel way of writing it. We would write it as meters per second. Why per second? Well, if the distance is longer, you may take more time. If the distance is shorter, you may take less time. However, we want a single representation. So it is always considered as the distance travelled per second, the distance travelled per minute, per hour, per week, per year, and so on. It will depend upon what we are talking about. Well, so this is what is speed, and we all know about it. It is how fast do you cover the distance. Now, the other day I was supposed to play badminton with my son. I am not a good player. He is too good at it. Okay, and I don't know why I came to know from the television that the speed of the wind is 3 meters per second. And I was like, wow, because that is going to add to my speed of hitting. And I was so elated, happy. Okay, and then when we were about to take our positions, I was, if this is the badminton ground, then if I stand here, the wind will be opposite. It will reduce the speed of the shuttlecock. Whereas if I stand here at position B, it would support me. Did you realize just knowing the speed is not enough? Just knowing that the speed of the wind is 3 meters per second is not enough. I need to know the direction of the wind, whether it is blowing from B to A or A to B, in order to realize whether it will be helpful to me or not. In other words, there are cases where, along with the magnitude, 3 meters per second, we also need to know which is the direction. Hence, we have another physical quantity, which is a cousin of speed. We can say that. Okay, and it is called as velocity. So what is velocity? Velocity is speed, but we keep the direction in mind. We will definitely care for what direction is the wind blowing, what direction is the river flowing when you try to swim across it. Okay, so because the direction is in the picture, we will call it as a vector. So in other words, when we just care for how fast or how slow the body is moving, only the magnitude, it will be speed and it is going to be scalar. But if the direction is going to play a role, then it is supposed to be a vector. and we will call it as velocity. It's easy to remember. S for scalar, S for speed, V for vector, V for velocity, but only in this case. Okay? So, now let us put these in proper words. So, let us jot down the important things together. Let us begin with the definition. So, speed is defined as the distance covered, if you remember it is distance upon time, as the distance covered by a moving body, in unit time. Unit time because we always express it as 60 kilometers per hour, 60 or 2 meters per second. Okay, so per hour, per second, per minute in unit. Per means unit, right? Unit time. Well, and velocity is defined as the displacement in unit time. So this is a scalar, so we will consider the distance because the direction did not matter. Whereas here the direction did. So velocity is defined as the displacement of a body in unit time. There are multiple ways of expressing it. You can also say the rate at which displacement takes place. So, do check what your school teacher has made you write, and I would say that please go with it. This is for better understanding, and if your teacher doesn't mind, well and good. Okay, so this is the definition. Now, the second part is, of course, as we did earlier, it is a scalar quantity. S, and it is a vector quantity. V, that's only in this case. And as we discussed in distance and displacement, there is one similarity. The SI unit, System International, SI unit is meter. By now you should be accustomed to writing like this per second. However, we have other units. SI units are also called as MKS system. Okay, meter, kilogram and second. But there are smaller units like centimeter per second. This is called as CGS system, and a practical unit is kilometers per hour. Right? Now, if you remember what we discussed just now, this is also knowing how much did it travel. It is also like speed, but we have also roped in the direction. We have also considered the direction. Hence, it's a vector. But the unit will still remain, the SI unit will be meter per second. And the smaller unit, the CGS unit is centimeter per second. And kilometers per hour is sometimes written as kmph. Okay, so this is everything in a nutshell. You have the definitions. They can be asked individually. You may be given a list to classify. So speed belongs to scalar quantities, velocity belongs to vector quantities, and the only similarity is the units. And if you are asked to distinguish between them, the points are ready, the blue and the red. So everything in a nutshell. So if I tell you that the speed at which I drive my car was 75 kilometers per hour, it means every hour I was covering 75 kilometers, right? But it is not necessary necessary that every minute also I covered the same distance. I don't mean 75 kilometers, okay? It doesn't mean that every minute I was covering equal amount of distance. So, when I started the car, according to the pickup of the car, it will take certain time to reach 75. It started from 0. So, it was 0. It increased gradually to reach 75. And maybe then I can maintain it stable. However, when I approach a speed breaker, I will definitely slow down so that I don't experience a jump. In other words, the speed is going to change. Let us take another example. Sometimes it so happens that you can make out that the signal is soon going to turn red and you may have to wait for some time before proceeding ahead. At such times I try to speed up so that I can cross it before the signal turns red. So at that time maybe my speed is not 75 kilometers per hour, it is more. In short, in actual life, in practical examples, the speed may not remain same always. So we will call it variable speed. Variable speed. When a body covers, not just variable, it changes, it is not the same, it is not equal, and hence the word unequal. Distances in equal intervals of time. Equal intervals of time. It is said to have variable speed. I hope you can correlate with the words unequal and variable. So that is what we experience in everyday life. And of course, it is not necessary that the speed is always variable. Let us talk about the watch. The hand of the watch. If you talk about the seconds hand, it covers one circle in 1 minute. The minute hand, it covers one circle in 1 hour, isn't it? Okay, and if you talk about the hour's hand, it covers 2 circles in 1 day. So of course, it manages to have cover equal distances in equal intervals of time. In that case, we will call it uniform. Okay, so let me put down the definition for uniform uniform speed. So, what is uniform speed? When a body, just try to correlate the two. When a body, and remember the example of a clock, equal distances in equal intervals of time. When a body covers equal distances in equal intervals of time, it is said to have uniform speed. So, time interval will be same, but if it is unequal distances in equal intervals, variable. If it is equal distances in equal intervals, then it is uniform. So as we saw, it is quite possible that Even though I claim that I was driving at a speed of 75 kilometers per hour, there are times when it will be less than 75, more than 75. So, in order to solve some practical problems from everyday life, we need a number, a single number. Okay? In that case, we deal with something called average speed. Average speed. Regardless of the change in the speed, we calculate it as total distance traveled upon the total time taken for it. In short, if I traveled 150 kilometers in 2 hours, then my speed is 75 kilometers per hour. Whether I try to increase the speed at the green signal or reduce it at the speed breaker, it just doesn't matter. We are simply taking the total distance upon the total time. Okay? And let us remember one thing. Speed is a scalar quantity. So it can be either equal to 0 or greater than 0. It will never be less than 0. Speed will never be negative. Speed would never be negative. After speed, it will be easy to define relevant terms with velocity. Let us talk about uniform velocity. So, uniform velocity, as the name suggests, it is going to be uniform. It is not going to change. Right? So, let us try to define it. If a body has, now it's uniform, same. Okay? So, let us use the word equal. Equal displacement. Equal displacements in equal intervals of time. Equal intervals of time. It is said to have uniform velocity. It is said to have uniform velocity. I hope you can correlate between the word equal and uniform. Same. Velocity. In the same way, if you try to recollect the definition for variable speed, we can define variable velocity easily. Okay? So let us try it. Variable velocity. So as the name suggests, it's not going to be same, it is going to change. So let us say, if a body has unequal displacements, mind you, variable, unequal. Variable means changing, unequal displacements. In equal intervals of time. In equal intervals of time. Okay, the time interval is same, but the displacement is unequal. Because it's velocity, it is displacement. Because it is variable, changing, it is unequal. It's said variable velocity. I will request you to pause the video and go through both the definitions. Now, let us consider variable velocity. When will the velocity be variable? We said when there is unequal displacement. Let me draw your attention to the fact that velocity is a vector. It is a vector quantity. So it has got magnitude as well as direction. So when will I have unequal displacement? There are three cases. The magnitude can change. Instead of 75 would be 80, it would be 60. So magnitude changes. Change in magnitude, or it could be change in direction. We just discussed about the speed of the hands of a clock, right? It must be having uniform speed or variable speed we talked about in other cases, but its velocity is not uniform because its direction changes. Because when the watch is moving, okay, so when it moves, the direction changes. I was moving like this, now I'm going down, backwards, upwards, so on, so forth. So it will change if there is a change in direction or there is a change in both magnitude plus direction. So we have to be very careful when we talk about variable velocity. Even if the speed is same, we have to cross check the direction. Okay, so quickly have a look at uniform velocity and variable velocity. So now that we know about variable velocity, we know that there is going to be a velocity before the change and velocity after the change. And we need to use some letters to identify what is what. So in general, velocity is represented as V. However, if it changes, then there will be two types. That is, before the change, initial velocity, and after the change, final velocity. So, the initial velocity is represented by U and the final is represented by V. At times you may get confused, so it is very easy to remember. When you write ABCD, initially you write U, so it's initial velocity, and finally you write V, so it is final velocity. I mean STU UV. Okay, so U is the initial velocity and V is the final velocity. Now, talking about average velocity. Unlike average speed, here we will calculate it mathematically. So, average velocity would be, there are two types, so the sum of the two divided by 2. So, it's going to be final velocity plus initial velocity. If you remember mathematics, you've done what is mean, what is average. So it is the sum of the observations, final and initial, upon the number of observations. So there are two, final and initial. So we divide it by 2. So numerically, symbolically, it will be V plus U divided by 2. That is average velocity. And whenever there is a question based on average velocity or average speed, you have to really be very attentive and use the correct formula. Okay? So, this is the first in-text question of your textbook on page number 102. And the answer would be, so speed is defined, speed is defined as the distance covered, if you remember it is distance upon time, as the distance covered by a moving body in unit time. Unit time because we always express it as 60 kilometers per hour, 60 or 2 meters per second. Okay, so per hour, per second, per minute in unit. Per means unit, right? Unit time. Well, and velocity is defined as the displacement in unit time. So this is a scalar, so we will consider the distance because the direction did not matter. Whereas here the direction did. So velocity is defined as the displacement of a body in unit time. There are multiple ways of expressing it. You can also say the rate at which displacement takes place. So, do check what your school teacher has made you write, and I would say that please go with it. This is for better understanding, and if your teacher doesn't mind, well and good. Okay, so this is the definition. Now, the second part is, of course, as we did earlier, it is a scalar quantity. S, and it is a vector quantity. That's only in this case. Well, this is the second question of the textbook, that is the in-text question on page number 102. It reads as follows: under what condition or conditions is the magnitude of the average velocity, which is a vector, of an object equal? It has to be equal, we have to equate them to its average speed. Well, this is a scalar and this is a vector. So we will have to ensure there is no problem with the direction. So the answer is obvious. This is going to happen if and only if the body moves along a straight line. Average velocity would be equal to average speed. Right? So the answer is actually, what you have to understand is only if it moves along a straight line, then there is no issue with the direction, hence this is the answer. So the third question on page number 102 of your textbook is, what does an odometer of an automobile measure? Well, odometer, whether you own a bike or a two-wheeler apart from a bike or a car, you will always see that there is 1 meter which has got like many blocks and a few numbers here and there, and it says kilometers. And when you try to sell it or purchase a second hand, you must have heard elders, grown-ups often discussing how much has it traveled. That's exactly what the odometer measures. So the odometer measures the total distance, the distance traveled. It would not be wrong to say the total distance traveled by the body. The total distance traveled by the automobile. Right? So, after you finish this part, please go and check where is the odometer in the vehicle in your house. So, this is the fourth in-text question on page number 102 of your science textbook. What does the path of an object look like when a body is in uniform motion? Well, first we have to define what is uniform motion. So, uniform motion means constant speed, right? And speed is a scalar quantity. If you remember, speed is a scalar quantity. So the direction has no role to play, right? So if you are sitting on a giant wheel which is mechanically operated, so after a certain time the speed remains constant. Okay, so even though the direction changes, it's an example of uniform motion. Okay, or if a pendulum is moving with the same speed, although it is moving to and fro, the speed is constant, so it is uniform motion. So whether you move in a serpentine fashion or like this, or like we had an example of a farmer moving along his farmland. Okay, so as far as the speed is constant, the shape will just not matter. So you may draw any shape to indicate the path. And the fifth question on page number 102 of your textbook is, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. This is time. What was the distance of the spaceship? We are asked distance from the ground station. The signal travels at the speed is given to us of light, and that is given to us is 3 into 10 raised to 8 meters per second. It is advisable to remember this value. Speed of light is 3 into 10 raised to 8 meters per second. Well, at no place have they mentioned that the spaceship is moving. So we just have to consider that it is stationary, and the distance has to be calculated while the time is 5 and the speed is given this much. Well, as I told you earlier, you may pause and read the question again. It is always advisable to read it twice. So let's jot down the data. So distance is to be calculated. Time is equal to 5 minutes. But as I told you, the SI unit and even the smaller unit is seconds. So we have to convert it into seconds. 1 minute is 60 seconds. So 5 minutes give us 5 into 60, that is 300 seconds. Right? Okay. Now the speed is given to you. Speed is equal to 3 into 10 raised to 8 meters per second. We need to learn and get habituated to this form. Right. So you know that distance is equal to speed into time. So we will use that formula over here. Distance is equal to speed into time. So that is going to be 3 into 10 raised to 8. It is advisable that in the first step of the numerical, you put the units. Okay, and the time is 300 seconds. So if you multiply, now you can ignore the units. Okay, so these two will add on over here. So 3 3s are 9, and the 2 zeros add over here and give us 9 into 10 raised to 10 meters. So the distance is this much. And how would you write the answer? The spaceship is 9 into 10 raised to 9 meters away from the ground station. It was a very simple one. So, the second sum of the textbook exercise from page number 112 is Joseph jogs from one end A to another end B. A to B of a straight, this matters a lot, of 300-meter road in 2 minutes 30 seconds. So we have to realize that everything has to be converted into seconds. And then turns around. Turns around means a U-turn, reverse. And jogs 100 meters back to point C in another 1 minute. What are his average speeds and velocities? So we have to find speeds more than once, velocities in jogging from, from A to B and B to C, right? So we have underlined the keywords, and now let us understand one thing, that let us make it little pictorial, okay? So let's say that this is A and this is B and this is 300 meters. This is 300 meters. So he went like this, and the time taken was 2 minutes and 30 seconds. So first of all, let us convert this 2 minutes 30 seconds into seconds. So 2 minutes 30 seconds is equal to 2 minutes. 1 minute is 60 seconds. So 2 minutes is 120. So 120 plus 30, that is 150 seconds. Okay. So let us write it as 150 seconds. 150 seconds. Okay. So it will be more comprehensive. And let us finish this part first, because part A is A to B. Well, so let us discuss the average speed. Now, average speed, if you remember the formula, average speed would be total distance. If you do not remember, you may rewind a little bit, and we did a few moments ago. Total distance upon total time, right? We are dealing with A to B. A to B. Right? Okay. Let us write here also A to B. Right? So, now the total distance from A to B is 300 meters. As I told you, in the first step it is advisable to write the units, and the total time is, as we converted here, 2 minutes 30 seconds or 2.5 minutes is 150 seconds. So it is very obviously 2, right? So the speed is 2 meters per second. Average speed from A to B is 2 meters per second. And since it is in a straight line, straight road, we have done this question a few moments ago, that if it is straight line, then average speed and average velocity remain the same. So let us work it out. Average, now there is no change. So average velocity will be what? Total displacement. Let me use another color. It will be total displacement upon total time. Total time taken. So the displacement is also from A to B. So it is 300 meters upon 150 seconds. So it's the same thing, 2 meters per second. So this also justifies our earlier answer, that when anything travels in a straight line, then the average speed and average velocity remain the same. The average speed the average speed from A to B, from A to B is 2 meters per second, and the average velocity is also 2 meters per second. Okay? Now, this part of the question is done. This part is answered. Let's move to the second part. Moving to the second part of the question, that is A to C. So what is C? You can very well see over here, then turns around and jogs 100 meters back to point C. So let's mark the backward journey in black. He returns 100 meters and this is C. Okay, this is 100 meters in 1 minute, in another 1 minute. So let us say 60 seconds. So now for this case, that is A to C, I would like to write here A to C. We have to calculate the average speed and the average velocity, right? So let us understand, what is average speed? Well, average speed would be total distance, the same old formula, total distance divided by the total time taken. So total time, right? Okay, now let us understand the total distance. He went 300 meters from A to B, and when he returned, he covered another 100 meters. So the total distance would be 300 plus 100. I remind you, we are working from A to C. So the distance is 300 plus 100. It is distance. The direction just does not matter. For the first part, the blue part, A to B, the time used was 150. And for the second part, that is 100 meters, he used 60 seconds. As I told you, in the first step, it is advisable to write the units. So we get 400 meters. No need to write meters over here now. 400 upon 210. Okay, so the zeros get cancelled. Okay, so it will be 21 ones are, and what will remain now here? It will be 19 upon 21 meters per second. You might as well leave it as 40 upon 21. Let us check it, 21, 40. So this is the answer, average speed. But for average velocity, we need to rack our brains. Okay, shall I do it here? I'll do it with black. Okay, so what was average velocity? Total displacement upon total time. So average velocity was total displacement upon total time, right? Now we need to think, what is total displacement? Let's go back and recollect what is displacement. The minimum distance between the initial and the final position. So what is the minimum distance between A and C? Out of the 300, we have to cut out the 100. So A or C kitne dur hai? 200. Because 100 meters to lord kya gaya? He came back. So it is going to be, am I clear? I'll repeat, he went 300 and returned back 100. So how far is he from A? So that is 200. So it is 200 meters. However, the time taken is still 150 to travel from A to B and 60 to return from B to C. So it is these many seconds. So it would be 200 upon 210. Let me write it again. 210. So the zeros get cancelled. We leave the answer as 20 by 21 meters per second. Now, since the direction changed, there is a difference between the average speed, which turned out to be more than 1, almost 2, okay, and average velocity, which is not even 1, or you can say almost 1. Okay, so this is the way we solve the sum. You have to be very careful about the velocity part, the displacement part. Okay, if you have any doubt, either put it in the comments below, or you may rewind this and see it again. So this is the third question of your textbook exercise on page number 112. It says, Abdul, while driving a school bus, computes the average speed for a trip to be 20 kilometers per hour. On returning along the same route, it's the same route, right? There is less traffic and the average speed for a trip is 30 kilometers per hour. Because there was less traffic, he could rush and he saved time, and the speed was 30 kilometers per hour. What is the average speed for Abdul's trip? Which trip? Janika, Kyanika. Basically combined, okay? To and fro, okay? Now, it's very clear. There are two journeys. One is to and the other is fro. Their individual average speeds are given. We are supposed to calculate the average speed for the entire set. It's to, fro, right? And let us just recollect the formula for average speed. Average speed is total distance upon total time, right? So, time is not given, distance is not given, what to do? So what we will do is, we will assume the distance, okay? There is no option but to consider that let the distance be x, right? So let us begin here. Let the distance be x meters. Now the answer is in kilometers, so we will get kilometers, right? Let the distance be x. So we will know the total distance while going x, while coming x, right? This is by rough work, so we know x and x, but we need to know the time also. So distance 1 is x, distance 2 is x. Let us understand what is the time taken. Well, we all know speed is equal to distance upon time. So let's swap their places. So time will be distance upon speed. That is solving our problem. So during first trip, right? Distance is equal to x kilometers. Speed, the first speed was 20 kilometers per hour and time is equal to unknown. But we know that time is equal to distance upon speed. Okay, hence we will get x kilometers upon 20 kilometers per hour. Okay, so you will get x upon 20 hours, right? It is weird, but that's all we have now. So I'll just quickly repeat. ना तो हमें distance दिया है, ना time दिया है, only speed दिया है. But we have to solve it. अगर question है तो solution भी होगा. Okay, so we assume let the distance be x kilometers. So during the first trip, okay, during the first trip, the distance is, as we assume, x kilometers. The speed is given to us. When you know the distance and you know the speed, you can very well compute the time. And that is T1 is equal to E1 upon S1, and we'll end up with T1 is टेढ़ा है पर मेढ़ा है. So let us put the data in a tabular form, like while going and while returning, the distance and the time. So जाते समय distance x or time x by 20, which we calculated just now. Okay. While returning, distance is x. We need to calculate the time. And the speeds, as we know, they are 20 and 30. Okay. So let us calculate the next part, and that is second trip, right? That is from the average speed here to here. Okay, so second trip mein we will have the distance, as we assumed the distance to be x, right? And the speed in the second part is given as 30 kilometers per hour, and obviously this is also kilometers. Okay, so here, as we calculated earlier, time would be distance upon speed, right? This will save a little bit of space. So it is going to be x kilometers by 30 kilometers per hour. Get accustomed to this. So the answer is x by 30 hours, right? The second part, time taken is 30, x by 30 hours. So it is going to be x by 30 hours. So although I am rubbing the board, I am putting the required data in the rough side. So we have the distance in both the cases, the time taken in both the cases. Okay, so I am rubbing this. After the first part, this would have been easier. Now, together, to and fro, going and coming. Okay, together, we have to find the average speed, right? So the average speed for the entire journey, I repeat, to and fro, is total distance upon total time. Total time. That was simple. So distance, while going, जाने का x, आने का x, same route. Okay, so that's going to be x plus x. I am writing the denominator with a different color so that it becomes easier. Okay, so the time taken was जाने का x by 20, आने का x by 30. It's x by 20 plus x by 30. The red part is the denominator, and I kept it red so that you know it's a totally different thing. So we will get, the black part will give you 2x, but the red part, they are fractions. So we need the LCM of x by 20 and x by 30. What is the LCM of 20 and 30? It is 60. The LCM is 60. 2 and 3 का LCM 6 है, so 20 और 30 का 60 होगा, right? Now, you've done it in your lower classes, but जिनको याद नहीं, इन दोनों का LCM 60, तो आप इसको 60 कैसे बनाएंगे? 20 into 3. Numerator बुरा बन जाएगा, उसको भी into 3. Okay, so you will get something like 3x. Okay, and यहाँ पे what will you do? How will you make this 60? Into 2. Numerator into 2. So when you cut them now, you get what was there originally. Okay, so you will get 2x. Okay, you've done this in your lower classes. You need not do it. For those who don't know, for them I did it, right? So it is what? 2x upon, the red part is 2x plus 3x is 5x upon 60. Now this 5x upon 60 is 1 upon 12. So you have 2x divided by x upon 12. 2x divided by x upon 12, which is a fraction. So division by a number means multiplication by its reciprocal. So if you want to divide 2x by x by 12, you can multiply it by the reciprocal of x by 12. तो x by 12 का reciprocal क्या है? 12 upon x, x and x cut. I repeat, अगर आपको ये red से divide करना है तो आप red के reciprocal से multiply कर सकते हैं. ये भी आपने lower classes में पढ़ा है. Okay. So your answer is simply 2 into 12, 24. Since it is average speed, it has to be kilometers per hour. Right? So the question was, what is the average speed of Abdul's trip? The average speed of Abdul's trip is 24 kilometers per hour. That is it. I will request you to rewind the video and see it again. In fact, So, this is the 10th sum on page number 113 of your textbook. It is the 10th sum of the exercise. It says, an artificial satellite is moving in a circular orbit. The shape really makes a lot of difference. And because it is circular, the radius is 42,250 kilometers. Calculate the speed. We are supposed to know the speed. If it takes 24 hours to revolve around the earth. So this is the radius and this is the time. We are supposed to calculate the speed. Well, because it is satellite, we will keep it in kilometers per hour. Because in any case, it is given in kilometers and hour. As I told you earlier, it depends upon the situation. So, we have got to find the speed, right? And you are given that the distance is actually the circumference because it is a circular path, so we need the circumference, right? So it's going to be 2 into pi into r. So that's 2 into 22 upon 7 into 42250. As of now, we will keep it as it is. Since it is distance, it will be kilometers, right? The time taken is given straight away as 24 hours. Don't be surprised if it is given as 1 day and you have to convert it into 24 hours. Well, now speed is equal to distance upon time. We've known this formula really very well. So, distance is 2 into 22 upon 7 into 42250 divided by the entire thing divided by 24. Now, division means multiplication with the reciprocal. So, we'll make it multiplication with 1 upon 24, and that becomes far more easy. So now we can simplify them, right? So 2 1s are 2 12s, 2 6 are 2 11s, right? 6 1s are 6 7s are 42. 6 does not divide 2. That is evident when we put 0 here. So we're left with 25. 6 4s are 24. 1 remainder. 6 1s are 6. 4 remainder. So 6 6. We are not interested in more than 2 places after decimal. Now, just to avoid any confusion, I will write it below. So it is 11 into 41.66 divided by 7. So let us simplify it. 7 1s are 7. This is 0. Even 4 doesn't get divided by 7. Another 0. Now we have 41. Because 7 6 are 42, so it will not divide. 7 5s are 35. 6 remainder. 7 9s are 63. There was a decimal here, so we will get a decimal here. 9s are 63. So you are left with the 3. 7 5s are 35. We will not go beyond 2 digits after decimal. So now we have to simply multiply 11 by this number. So if you go by Vedic maths, let me use a red pen. Nothing plus 5 gives me 5. 5 plus 9 gives me 14. This is again 14 and 1 15. 5 and 1 6. 0, 1 and 1. You can calculate it by a calculator and check it. So the answer is these many. The answer is 11,065.45 since it is speed kilometers per hour. However, in mathematics, which is also part of physics here, we cannot be leaving such a big number like this. We want to have the decimal here. We want to have the decimal here. So the answer would be, let's see how many parts, how many steps it jumps. So it's like a 1 and a 2 and a 3 and a 4. So it is going to be, the answer is going to be 1.1 into 10 raised to 4 kilometers per hour. So the speed of the satellite which revolves around the earth is 1.1 into 10 raised to 4 kilometers per hour. I would request you to rewind and see the sum again. That's all.